This lesson is on lines and angles. Three objectives in this lesson. First of all, I want you to be able to identify parallel, perpendicular, or skew lines. Three different categories of lines and relationships between lines. Number one, parallel. There's a symbol we use to represent parallel, or to represent that word. It looks like this. It's just two long parallel lines. Perpendicular. With that symbol, or skew lines. Okay? Parallel, perpendicular, skew lines. I want you to be able to identify them and understand what those words mean. Objective number two. I want you to be able to identify angles that are formed by a transversal. I haven't defined what a transversal is yet. I'll do that in just a short time. Identify angles formed by a transversal. And number three, I want you to be able to use the parallel line postulate and the perpendicular line postulate. I'm already assuming you know what these symbols mean. This says use the parallel line postulate and the perpendicular line postulate. So these are the three objectives that you should be able to come away with from this lesson. All right, so the first thing we need to be able to do is identify parallel lines, perpendicular lines, and skew lines. To make that a little bit easier, we should define those terms. Parallel lines are coplanar lines that never intersect. Coplanar lines that do not intersect. Some examples, for instance. When you're driving down a surface street here in town, you might see down the middle of the road two yellow lines side by side. And if you continue to follow the lines, you'll find that they never intersect. That's a good example of parallel lines. Of course, it breaks down if you start going down hills or around corners, and you sort of get into problems there. But you can see this idea that two lines travel. Railroad tracks, same thing. If you follow the railroad tracks, they simply don't intersect, hopefully. And so that's a good example of parallel lines. The truth is, these things are all around us. If you look up at the ceiling in the classrooms, you'll see that there are these grids that hold the ceiling tiles in place. They're straight. They go all the way across the room. They never intersect. And you can imagine that if we were in a really, really long room, maybe one of the hallways, you wouldn't see those lines intersect there either. If you look in the corners of the rooms that you're in, right now probably, you have a situation where two walls meet. The corner of the room is represented by a line, the intersection between two walls. Another corner of the room also represented by a line, intersection of two walls. And those intersections are lines that are parallel. They run up and down, and if you were to extend them straight up and straight down, they wouldn't meet. Parallel lines. Perpendicular lines now. Perpendicular lines are lines that intersect at right angles. Lines that intersect at right angles. Again, if you direct your attention upward toward the ceiling in the classrooms in the school building, you'll notice there are these grid lines that hold the ceiling tiles in place. And so you have a set of grid lines that runs across the room, and you also have a set of grid lines that runs in the other direction, perpendicular to it. They intersect at right angles. Lots of times T-intersections at roads would be a good model. Perhaps you have a situation like this, where a main road goes east and west and another road comes up from the north and intersects. And these might be perpendicular. We might indicate that with a little square in the corner. We've looked at that already. So perpendicular lines are lines that intersect at right angles. It's important that they intersect. Just because one goes up and down and the other one goes left and right does not mean they're perpendicular lines. They have to intersect in order to be perpendicular lines. The third kind of line that we run into are line pair, are skew lines. So we have parallel lines, perpendicular lines, and then sometimes we run into line pairs that are skew lines. Skew lines are lines that are not parallel and never intersect. Not parallel and never intersect. Sometimes we have a little bit of trouble imagining this, and the primary reason is because it's really difficult to draw lines that are skew lines on paper. In other words, skew lines always exist in 3 dimensions. It's impossible to have skew lines in 2 dimensions. Let me show you why. If I try to draw skew lines here on the whiteboard, there's no getting around it. They intersect. There's just no way for me to draw 2 lines on the board that don't intersect. You say, well, wait a minute, Mr. Picard, what if you draw them like this? Those lines don't intersect, yeah, but they're parallel actually, right? If I continue them on forever, they'll never intersect. Well, what about these 2? These are not parallel lines, and they don't intersect. Well, that's not exactly true. They're segments of lines that appear not to intersect, but the lines that contain those segments actually do intersect. And you find, watch this, if we just extend the line segments to identify the lines that contain them, you'll see that I have ruler difficulties. You'll see that they intersect right there. So these are not parallel lines. They're not perpendicular because they don't intersect at a right angle. They're not skew lines because skew lines never intersect. These are just plain old intersecting lines. We don't have a special name for them. Okay? So how do we represent skew lines? To do that, we have to step outside the paper, so to speak. We need to step into 3 dimensions in order to do that. One of the easiest examples I can give you is I assume you're in a room right now. If you sort of look up around the room, you might find that there is an intersection where a wall in the room meets the ceiling. So this is a wall, and this is a ceiling. Okay, a wall and a ceiling. And there's a line up here. Now, if you sort of turn and look behind you, there's probably another intersection somewhere in the room where another wall meets the wall that's behind you. So this intersection here. Okay? This intersection here across the top of one wall, and this intersection here along the edge where 2 walls meet together. Those are skew lines. You can see if I continue this line up forever, or down forever, it will never intersect this line here and the extensions of this line here. They're never going to intersect. Neither are they parallel, right? You can see they're not coplanar, so they're not parallel. Neither are they perpendicular. Those are skew lines. They never intersect. That one's a little bit harder. I encourage you to look around if you want to think about maybe your bureau in your room. If you have a bureau in your room. If you have a bureau, maybe it looks like this. Approximately like that. If you consider this top edge here, and think about the extension of it that would go off infinitely in this direction and in that direction, and then think about this back edge here, this vertical back edge here, and its extension infinitely below and above. Those would be another good example of skew lines. They don't intersect, they're not coplanar. Again, skew lines never exist in 2 dimensions, which is why they're hard to draw on paper. They always exist in 3 dimensions. They're lines like these that neither intersect nor are coplanar. Okay? Skew lines. The next thing we need to do is identify the angle pairs that sort of come into existence when we draw a transversal. Now before we do that, I have to identify what a transversal is. I need to define that for us. So transversal. A transversal is a line that intersects 2 coplanar lines at 2 distinct points. Let's just take a look at what that is. We'll start with a really straightforward example. If I have 2 coplanar lines, such as these 2, those are 2 coplanar lines. A transversal is a third line, that intersects both of them at 2 distinct points. So I may have line L and line M, and then line N is my transversal. That is my transversal right there, that line. Okay? Now, these turn up all over the place as well. The important thing to understand is that as we work with transversal lines, we constantly shift our focus around. So maybe at one moment I'm looking at line L, and then maybe I'm looking at line N. If I'm looking at line L in this diagram, line L is not a transversal. In this diagram, it's not intersecting 2 coplanar lines at 2 distinct points. But line N is a transversal because it intersects L and M at 2 distinct points here and here. So that's the definition of a transversal. Now we need to identify some angle pairs associated with every transversal. To make that a little bit easier, I'll just number some of the angles that have occurred in this diagram here. This will be angle 1, 2, 3, 4, 5, 6, 7, 8.